why AI? What is it all about? So, big first question, of course, is what is AI? In the press and everything at the moment, AI is completely associated with the new large language models, ChatGPT, Copilots, and so on. This is a misconception, of course, because AI is actually a huge subject, a huge range of tools and methods, of which machine learning is just a part of that. And artificial neural networks are just a part of machine learning. And then we've got deep learning, which is a part of artificial neural networks. And then there's these large language models, which is just a part of deep learning. Though it's true, though, that yes, the large language models have completely revolutionized people's views of AI, and brought them very much to everyone's thoughts. But what is AI? I mean, originally it is or was an attempt to make machines think. Um, Started back in, I think, the 1950s, where the idea was a symposium of some clever chaps could come up with an understanding of how people think in about 6 months. And 70 plus years later, we're not there. Instead, what we've got really is a whole range of other tools. So things like natural language processing, um, understanding speech patterns, understanding grammar. In fact, you'll see these in the output of this is in grammar checkers, unsorted database searches, um, which have been around for about 30 years now. Well, at least in terms of internet searches. That's why companies like Google are so big in AI. They've been doing AI for decades. Machine learning from machine generated models. Um, this is a particular interest in the engineering world because this is where optimization comes in. You know, you start off the model and you keep change the model until it achieves the goals that you're seeking. Machine learning from external data sources. Um, this is more what people think about of machine learning, and certainly so this then feeds into things like deep neural networks, where the neural networks are based on or inspired by how brains work and neurons connect to each other. And this then leads us through to things like surrogate models, where you can, let's say, doing optimization, you can set up a number of standard models with on a range of variables, and then you can train a neural network to say these are the corner points and key points and so on, and then say search through to say where's the likely best design to be, and so that's much quicker than to do recreating models all the time. But the key thing about machine learning is that they are not programmed, they are taught. So we don't always know how they work other than the methods which got the information in there in the first place. And this is where things like large language models come in, which have been trained on um, millions and millions of text and articles and books and the internet, which of course we know is a source of all great knowledge, and so on. And they have proved hugely successful, or they appear to be anyway at the moment. Gartner published this thing called the hype cycle, where things are invented and then we have this huge hype peak, where everyone's overestimating what it can do. Then we realize actually it can't, and trough despondent, and then we finally work out what it can be used for. And we've seen in the past things like the dot-com cycle. In fact, AI neural network, for example, had a huge peak in the 1970s, and the trough despondent disillusionment then lasted for a decade or two until computing technology caught up with the theories. As far as large language models are concerned, I think we are at or maybe just passing the peak of inflated expectations. Though the ad companies are definitely keen to keep that peak hype going because they want as much funding as possible. But we'll be heading into the trough disillusionments, and ideally speaking, we then find out what it is that we should be using um, things like large language models for. So, first of all, think about why you should not use AI. It's not a given. So, for example, hallucinations or AI slop. This is an example of an image that I generated. Well, I asked the open.ai, give me a picture of two engineers looking at a model. And it gave me sort of 2.5 engineers with an indeterminate number of fingers between them. And yeah, at first sight, it looks great. Look in detail, the cracks begin to show. And this is typical of AI systems. They can be very confident. In fact, they're designed to be confident, and they're penalized if they don't appear confident, which means hallucinations and so on are actually built into the system. A bit like you've got new graduates, they're very keen, they think they know everything, and they're super confident, and they will give you the answers, even if the answers are wrong. And so we have to be careful. Validation and verification. Remember that these AI systems, they encapsulate knowledge, but not understanding. They don't actually understand anything, but they got data in and they process it and they sort of encapsulate this knowledge of what goes with what and so on. Also, that does mean they will encapsulate and embody bias and prejudice. So, for example, HR systems, if you train an HR system to recruit staff based on who you've already employed, then, I mean, in the case of the technology industry, that is typically male, pale, and stale. And if you train based on that, you'll just perpetuate those biases and prejudices. You will not be able to achieve diversity and change systems if you just embody the problems of the past. Also, they have no ethics or morality. And in fact, companies like Google and Facebook and so on did have ethics departments, but they sacked them all because, well, make your own conclusions of why they got rid of them. Also questions about data security and intellectual property. Certainly in many systems, ChatGPT, especially the free version, the data you put in will go and be stored. The questions you put in will be accessible later on. The documents you share and the text you put in could be used for training next time. And in fact, there have been a number of cases recently where some of the questions have been published that people have been asking, and very, very embarrassing. Other systems, they do when we use Arup, the data we put into the system there is kept within the company and not allowed to go outside. Um, they're also black boxes. So large language models can offer reason chains. Um, whether those reason chains are what the system actually used, or whether it's inventing a reason chain which sounds reasonable but it's actually nothing to do with what it actually does, we don't know. Yeah, these systems well, neural networks in particular, they're very much black boxes. They're very difficult to understand why particular decisions have come about. There's also the question of environmental cost. The cost of training these big, large language models is huge. The sorry, keep on the chat. So yes, yeah, the cost of training these models is weeks and weeks and weeks of data set center work. even the cost of producing these images, which I discovered afterwards, is can be quite intense, and they are not carbon neutral. There are efforts to make the data centers carbon neutral, and also, of course, maybe we can use them to help us become carbon neutral, but we're not there yet. Also, the question of future quality. If AI systems are trained on everything we've done before, and there's a certain amount of recombination of what's done before, where are the brand new ideas going to come from if we rely too much on AI? Some think if our Stone Age ancestors were using AI, we might now be living in very nice caves. But where the idea of buildings come from? We have to keep these human imaginations and ideas flowing. And on that note, also future career developments. At the moment, graduate engineers are put to work designing beams, working out bending moments, and so on. Whereas if the AI systems are giving the designs and then it's the senior engineers judging them, how are the junior engineers going to learn those judgment skills? This is currently an unknown. But on the other hand, there are many reasons why we can or should use AI, in particular, large language models. So, document searches. For me, this has been amazing. Um, you know, there's a clause somewhere in one of the Euro codes relating to something. They can search through all the Euro codes and find the clauses you're looking for. I've spoken with colleagues at Arup, and they say feeding all the clients and project specifications into the system, and then able to use it to search through all documentation to find the data and whether it's there or not. And then, of course, most importantly, avoidance of hallucinations. There will be references which you then got to click through and check to see they are actually correct or not. These systems can make stuff up, so always got to check. Optioneering. Maybe not large language models, maybe, but certainly many AI systems can help us with things like scheme design. What are the options we could use? Inspiration in that respects. Options on comparing different materials, different layouts. Questions on topology. Topology optimization is one of the trickier areas. And yeah, optimization itself, we can make use of systems, AI systems, to help us work out what is a more efficient structure. Different materials, different layouts, different column spacings. You can explore all these different options to give us ideas and approaches that we can then make use of. Also, of course, improved structural performance. These are all these potentials. There are many, many other good uses that we can put to for these AI systems. So it's very important to remember that AI can be very good and can be better than some of those individuals in some cases, but human plus AI is much better than an AI system itself. And we like to call centaurs. Best of human, best of, well, animal, machine, whatever. So use it, use these systems. Inspiration. Think of ideas. I've used it myself for, getting out of writer's block, or I have a presentation to do. I say, here's what I've written previously. Give me some slide suggestions. And they were okay, but it helped me then go, okay, why not okay, and then develop the slides from there, taking them as a starting point. Validation and verification, like all designs, have to be checked, no matter how qualified the person. Output from AI systems have to be validated and verified. Validation, of course, asking the right questions. Verification, are they giving the right answers? Because AI is all about approximation, limited understanding. It's quick but simple, and it's great for options, but not necessarily answers, or maybe answers which are close and so on. But anyway, always assess the answers and options it's giving. So how might we use AI in our education and research? So for example, education. Yeah, students will use AI. They will put your questions into AI and get answers out. And I've seen a number of cases where lecturers have said, okay, explicitly, I want you to use AI, give me the questions that you ask, give me the answers it gives, and then tell me where it's wrong. Also, of course, if AI is giving the answers, are we asking the right questions? What are the questions that we need the students to be thinking? Yeah, where are the human gaps, or the gaps? Yeah, the areas where the humans win out over the AI. Yeah, and of course, yeah, get them to explore what AI can do and what it cannot. Make sure they understand the advantages and limitations. And then questions like, how will these large language models change engineering? What are the long-term implications? Where can they help us? Where might they be a problem? How should junior engineers be trained? Those graduates. How are we going to turn graduates into senior engineers in an AI environment? And of course, what are the right questions where the AI is the best answer? So, in conclusion, recognize the hype. There's a lot of hype at the moment. Um, recognize that and understand that it won't last. We will go past it. Teach the students how to work with the AI. And also discover how we can best use AI in the industry. What's happened to the overlap? Never mind. Okay, and I will leave you with some relevant resources. Mentioned computational engineering earlier. Um, but also there's the Engineer of the Future is a Centaur, a structural engineer paper from 2020 now, working with AI, and there's a conference paper about what is the future role of structural engineers.